Kirchhoffs laws are a set of laws with which we can set up a system of equations and solve circuits. And so unlike the reduction method that we did, this is just like, we don't have to reduce anything, it's just algorithmic, okay? Now, complex circuits like we did lead to like 5 by 5 matrices, so it's better to do reduction if you can, but let's just go over what these laws are, okay? So the first law is the junction law. If you have a junction is just where two wires meet, and let's imagine that we have decided just arbitrarily that the current going this way is called I1, and we've decided arbitrarily that the current flowing this way is I2, and that the current flowing this way is I3, right? And you just decide these things. You decide. You make guesses where the currents are flowing, in what direction they're flowing, right? And by the way, if you're wrong about the direction, the currents just come out negative. It's okay. Okay, so in this case, I is flowing into this junction, I1 is, and I2 and I3 are flowing out. So our junction law is very simple. It's I1 equals I2 plus I3. Okay? So in the currents that flow in equal the sum of the currents that flow out. So basically what we're saying is that this river that is I1 splits into two rivers, I1, I2, and I3. Okay, so if this is 5 amps, this could be 2 amps and 3 amps, right? This is basically a conservation of charge. That is, if 5 coulombs a second flow into this junction, 5 coulombs a second have to flow out. This junction doesn't create or destroy charge, right? And then the second one is that if we add up all the changes in voltage, we'll end up with 0. If we do a complete loop, this is for a loop in a circuit. And this is like saying, basically it's the gravitational equivalent of saying, if I go for a run and start and stop in my front driveway, the net change in elevation of my run is 0. That is, I'm going to go up hills, I'm going to go down hills, I'll end up at the same elevation. Okay, and this is by far the hardest law, or the harder. I guess there's only 2 of them, so this is of the 2 laws, this is the harder. Okay, so as you traverse these things, keep in mind that this is the high pressure side, right? This is the positive side. That's the negative side of the battery. And if I traverse it this way, if in my path I go through this battery as I'm just making a loop in a circuit, and I'll show you some loops later, I'm going from low pressure side to high pressure side. So that would be plus 23 in my equation. And if I traverse the battery the other way, that is, I somehow travel in my loop calculating all the voltages, right? If I travel this way, that would be from the high pressure to the low pressure side, so that'd be minus 23. And that's pretty easy, right? Regardless of, by the way, any which way we guess the current flows in this situation, okay? Now, if it's a resistor, it has to do with the current, okay? As the current flows through this resistor, this is the high pressure side. This is the low pressure side. Think of it as like a pipe with gravel in it, right? As the water pressure is going to be higher on this side of the gravel, lower on that side, okay? That's why if your pipes are really rusty and narrow in your house, when somebody flushes the toilet, the pressure can drop in the shower and people yell at you, right? Okay, so if the current is flowing this way and we happen to traverse this thing, right? Remember that in Ohm's law, V is IR, right? So this is, say, let's call this I1, right? Okay. This is I times R is what I tried to write there, okay? Then this is going to be, if we go from high to low pressure, this is going to be minus 11 I1. Okay, so this is the resistance, that's the current. Okay, so minus 11 I1, if we go from this way, if we happen to traverse this resistor and we've guessed that the current is flowing this way and we're going upstream against it, we would say that that's plus 11 I1, okay? So if we go downstream, it's minus 11 I1. We're going down the waterfall. If we go this way, we're going up the waterfall. Okay? So let's just make some loops here. We're not actually trying to solve this thing. Do this on the front side of your note guide, if you would. Okay? So let's imagine that I do a loop like this. I'm not gonna, but let's imagine that I go clockwise. Oh wait, first off, let's guess that the currents are flowing like this. That we've got, I'm going to call this one I3. I'm going to call this one I2. And you guessed it. I'm going to guess. By the way, you can make totally absurd guesses. Like I could guess that all the currents are flowing into that junction and the truth will out. It's kind of like climate change. I mean, if it's really happening, we'll know, right? Okay, but I like to make guesses that make sense. So I'm going to guess that this current flows this way, the current flows this way, because that's the way that the current wants to flow in these cells, right? And then that all of it sort of travels down this way, right? Now, let's, okay, I got to escape here, and I got to pick a pen color. Let's pick red. Wow, it's going to be red pen. Now I'm going to traverse this thing, and what I want to do is I want to go around the outside of this. I'll go clockwise. Okay, I'm just going to show you an example of a loop equation. Okay, if I go around here, all of the voltages are going to add to 0 for this loop. Okay, notice that for the going through this guy that I'm going upstream against I1, so it's going to be plus 5 I1 is my first encounter, right? I'm going upstream through I1 through the 5 ohm, right? The next thing I encounter is 9. I'm going, it's I3 now, right? So it's going to be plus 9I3, right? Because I'm going upstream. Again, I'm going against the current. Remember, we just guessed the current's that way, but you know, that's okay, right? Notice that I'm going against the 23. I'm going from this side to this side, right? Okay, so I'm going to go down 23, right? And then again, I'm going to go upstream through a 3, so I'm going to go plus 3I3. Remember, this is, we guessed that we called that current I3, right? And then I'm going to go plus 4I3. I'm almost back, right? Okay, and now I'm going upstream against I1 again, right? And I never encounter I2 in this path, and that's okay. And then I get to this guy, and it's going to be plus 6I1, and now that's got to equal 0. Because I ended up back where I started, right? I went for a jog. I did all this stuff, right? So again, these guys are positive because I'm going against the current, right? Anytime all of the IRs, okay, if you go against the current, you're going upstream, you're going to a higher pressure, right? If you go backwards through a battery, you go down whatever that voltage is, okay? I'm going to do yet another example. If you understand the concept, please feel free to bail, okay? Let's do another example here. Okay, so let's imagine, let's go that our currents are, let's go blue. Again, let's say that the currents are this way. I'll call this guy I1. I'll call this guy I2. I'll call this guy I3. Okay, and let's go for a little run. Pen color, where is it? There it is. I want to be red again. Let's imagine that I go from here and I just go in this little loop here. Let's go anti-clockwise. Okay, so now let's do this. I'm going downstream in I3 through 4, so minus 4I3. Okay, the next one is minus 3I3. Now I'm going this way through the pump, right? So it's going to go up 23. Then I'm going to go down 9I3, right? Okay, now I'm on this part here. I'm going this way through this guy, right? I'm going to go that way. So I'm going upstream against I2. So it's going to be plus 7I2. You got to keep track of which current it is, right? Okay, then it's going to be, I'm going to go down 5 because I'm going this way through a battery, right? Or a cell. And then I'm going to go again plus 8I2. And I'm back now. Okay, and that's 0. So let's just check this, right? I'm going downstream through the 4. That's why it's negative. Downstream through the 3. That's why it's negative. I'm going from negative to positive, so it's positive 23. Downstream through the 9. That's why it's negative. Upstream through the 7, because we guessed that the current flows that way, right? I'm going the wrong way through the battery, so it goes down 5 volts of pressure, and then it goes up 8, like that, okay? So that's the basic equations. I'm going to solve the thing in the next video.